Welcome to lecture number 38, and you recall that we were discussing two connections YD11 and previously YD1 we have done, okay, and I hope you have got the idea what. And do not forget that not only the phase voltages, but also the line to line voltages suffer same degree of either lag or lead on both the sides. And then I have discussed about the clock this thing, and we found that there are two connections possible. So, YD11 or YD1. Mind you, if somebody says the connection is YD3, no, you cannot realize it, because these such voltages are not available. You must understand this point, is not? It so happens that 30-degree phase displacement only possible with star delta connections. Therefore, anything you cannot get means YD2, somebody says I have connected the transformer. This is ridiculous, you cannot get it for a balanced 3-phase transformer. This just I point out. So, you should be very methodical in drawing this. Okay. Now, let us connect the same way, but now rather quickly these connections, say D Y, I would like to connect. I am not mentioning the vector group yet. Suppose, and but I know there are two correct ways of connecting delta. So, primary I have to connect delta, secondary star, and two ways of connecting star. So, suppose I say that two valid delta connections are there. So, A1, A2, this is the primaries, B1, B2, and this is C1, C2, and one of the valid connection is go this way. That is first, let me try. So, this is the primary connection I will do, and obviously, from A1, B1, that is the convention I am following. C1 I will take the output, and not output, I will connect my source AS, BS and CS. This is what I will do. And secondary, small A1, A2. Small C1, C2. See, I have taken given input as if A1, B1, C1. So, I would like to have outputs taken from A1, B1, C1 on the secondary side. So, suppose I short it, star connection. Okay. Now, what I will be doing, I have to draw the primary voltage phasors, voltages coming across each winding. And as I told you, to begin with, you better draw supply voltage is balanced and phase sequence A, B, C balanced. So, what you do is this, you draw this vector diagram, that primary vector as this primary side is delta connected, draw it like this, with this is S line to line voltage I am drawing, BS and CS, is not. This is the balanced 3-phase voltage, what else, AB, BC, CA, they are 120 degree apart. Okay. Now, AS is connected to A1 and B2. So, I write here this point is A1 B2, either of them or together, same point. AS is connected to A1 and B2. Similarly, BS is connected to B1 and C2. So, this point is same as B1 and B2, no C2. Capital, and CS, as you can see, it is connected to C1 and A2. Same, CS is nothing but C1 and A2, is not? This is the thing. Acha, what is the voltage applied across the primary of the transformer A? A1, A2. Where is A1, A2? This is A1, this is A2. So, on the secondary side, this voltage will be, if I use a different color, it is parallel to this line, is not parallel to this line, and I will write it here A1, A2. Got the point. Similarly, B1, B2, voltage applied across the primary of the B transformer is B1, B2. Where is B1? Where is B2? Oh, this is B1, this is B2. So, parallel to this, small B1, B2 will exist, and not only that, I have joined B2 with A2. So, bring this line parallel and it will be here. B2 B1. Note B2 B1 parallel to this. So, this angle will be 120 degree apart. Mind you, all these angles are 60 degree. I hope you understand that geometry, which I am not going. And finally, voltage applied to the primary of the C transformer is C1 C2. Therefore, secondary induced voltage will be parallel to this C1 C2 line, and C2 I have joined. So, C1 left, C2 like this. All angles are 120 degree. I think you understand that. This is the thing. Now, if you choose a connection, you get it in this way, and now I have to decide what is the vector group of this connection. Primary delta D, secondary star Y. I want to know what is the vector group. So, what I will be doing? I will identify on the delta side there is no neutral, small neutral, that is artificial neutral or centroid of the triangle. So, this is the, and I will mark A1, A1, B1, C1. This is where I will follow the convention. I have connected supply. Similarly, this is my output. This is of course obvious in this case, no problem. Now, the A phase voltage of the primary side is this vertical line with respect to neutral. This is the secondary neutral. It exists, this point. This is secondary neutral. Now, this A phase voltage, if you draw this A phase voltage of the primary is this vertical line. So, this is 30 degree. It will be 30 degrees, and therefore, I will say that it is Y D secondary voltage lagging the primary voltage with respect to neutral by that I could write it minus 30 degree, or you could write D Y. What should be the time? 12 and this is 1. So, 1. Got the point? That is in terms of clock convention, because your this thing it is here Fs voltage, it is there. Therefore, this is how you, and also do not forget that line to line voltage here, that way also one can do that. Line to line voltage of the primary side is A1 B1. What is the line to line voltage of the secondary side? It is this one. So, this was this once again can be shown to be equal to 30 degree. That is what you must understand. Okay. Therefore, both the line to line voltages and phase to neutral voltages will suffer the same change, star delta connection. Okay. I will just the other connection, you can try delta this way, that you will decide and you will soon discover that okay, that will be OID1, that I am not repeating. But what I will say to you is this one. The same connection I will do in a slightly different fashion, just to make you understand. Suppose, see, in this connection, when I did, what I have done? I just told connect dy. I did not specify the phase angle difference. This to begin with, I did not know what it is. It looks like as if I have connected first, then told, oh, you have connected, this is this phase group. But suppose I want to connect dy1, oh sorry, suppose I now say that connect dy1, okay, the connection I know now. The point I want to make is interesting. You see, this is the three transformers you have, A1, A2. This is B1, B2, and this is C1, C2. Okay, good. And this is secondary, small a1, a2. One terminals are dot terminals, which I am not writing all the time, B1, B2, C1, C2, fine. Okay. Then what I am telling, you connect this as delta like this, for example, same thing I am doing, I mean do not worry, this is AS, this is supply BS and this is supply CS. Okay. Now, after you energize this, what I am telling, this is your supply voltages, because supply voltage I know it is balanced. So, I will write AS, draw this triangle 60 degree equilateral triangle CS, and then say that AS is nothing but A1, B2 etcetera, A1, B2, and BS is B1, C2, and CS, this is CS, CS is C1, A2. And suppose secondary I have not connected, that is what I am telling. I want to achieve this one connection. But what I know is this, that I have now in the secondary these phasors available to me. What is that? Small A1, A2, this is available. Then this voltage is available, C1, C2, and B1, B2. Why I have shown them in isolation? because I have not connected yet, I do not know. But since you want to connect dy 1, what you would like to have? Your A1 voltage with respect to neutral here, that is this voltage, secondary A1 voltage, small a1 must be, I mean that way. That is in the 12 o'clock, if this is your primary, you would like to have small a1 a2 here. So, this indicates that you better join a2 b2 c2. I mean, you ponder over this, think these are very interesting. So, such that this will be this way. And then say, okay, I have joined. That is in effect what I am telling. It is not that these connections are arbitrary. You can, I can tell you make this connection. Then the question is whether delta should be connected this way or delta should be connected that way. Connect it and try to get this one, achieve this. So, have practice on this. I think I have made things clearer now. So, this is the vector group. Similarly, you can have last connection here is delta delta connection. Star star connection is so simple. This I will just mention delta delta connection. Okay. So, delta delta connection means see, I have not yet told you which connection to use at in what application. I am simply now getting acquainted with you. What are the possible things you can do? 3 phase means star delta connection. It looks like okay, 3 phase transformer, 3 coils there, 3 coils there, either of them you connect. I am just telling you how to get the correct connections with confidence. So, that is the idea of this lecture. So, here also I say this is A1, A2, this is B1, B2. What are the vector group possible here? That is what I am examining with delta delta connection. Okay, and this is the secondary. Here I will not take much time because you are now used to it. Small b1 b2 and this is small c1 c2. Okay. Okay, proper delta I have to connect. So, these are dots. So, connect it. This is one of the proper way of connecting. And I will give supply, connect supply here AS to B1, BS and to this junction CS. Okay. Now, suppose there are only two possibilities here, this way you connect, secondary you connect, also this way, same way. Let us see what vector group it results into because of this connection. Proper delta connection, correct. Acha. Now, once again delta connection. So, better draw the primary voltages, line to line voltages first, because there is no neutral, that is why I start with line to line voltage. And it is the 3 phase balance, it has nothing to do with transformer, this is the supply voltages which are available here, is not. Line to line voltages are also balanced, ASBS, BSCS voltage lags by 120 degree, you know this, and CSAS voltage further lags by 120 degree. Okay. I am not putting the arrows, that is understood. Okay. ASBSCS like this. And then what is the next step? Oh, AS you have connected to capital A1 and C2. So, capital A1 C2. BS I have connected to B1 and A2. So, B1 A2, same potential because of this connection. CS is connected to C1 B2, C1 B2, is not? This will be the thing. Secondary voltages A1 A2 will be parallel to this line. So, A1 A2. B1 B2 will be parallel to this line, correct or not? B1 B2 will be parallel. So, B1 B2 I will put it here, bring it down. Okay. So, but B1 is connected to A2. So, B1 must be placed here, B1 B2, and finally, you bring this C1 C2, you get this same triangle. Where from I will take output to be consistent from A1, this I will call A, this I will call B, this I will call C, and this will be the thing. What do you think? So, primary is delta, secondary is also delta, small letter, and what is the phase angle difference? 0 degree, because here also no neutral exists, but anyway with respect to artificial, this is vertical line, here also this A phase, mind you, that is also parallel. So, time is 12, no, that is so DD 12 or 0 degree, whatever you call it. Now, the same primary connection, if I make say this is A1, A2, this is small A1, A2. I mean same thing I am drawing, you also draw, so that you get used to it, I mean small C1, C2, okay. And suppose primary I have connected like this, as I have told you, delta, and these are from the junctions, supply AS, supply BS and supply CS. This is known, and secondary I will now connect not this way, but other way. These are the only two possible delta connections. So, suppose this I have connected like this, and I will take output from these junctions, small a going to load, from B1s going to B, and from C1 going to C of the supplying load. Okay. Now, here it is so what should I do? Delta connection, draw supply AS, BS, CS. What is AS? A1, B2. We have done it, A1, B2. What is BS? B1, C2. And what is CS? CS is C1, A2, C1, A2, like that. So, A phase voltage, secondary voltage A1, A2 phasor will be parallel to this line, B phase voltage phasor will be parallel to this line, with this side small b1, that side b2, and C phase voltage. Okay. So, let me start with the A phase voltage. this will be small a1 a2 parallel to this, is not. B phase voltage B1 B2 and B2 is B1 B2 is where? This one B1, have I drawn correctly this? Wrong, sorry, there is a mistake here. See, A1 A2 is here, have I made A1 A2? So, A1 A2 here I should draw like this, correct or not? Small a1 small a2 parallel, small a1 small a2. B1 B2 is here, so that is parallel to this, but B2 is joined with A1. B2, where is B2? So, B2 is joined with A1, B2 phasor is this. So, B2 B1 and finally, I think I have done the same connection, is it? Looks like same thing. So, it will be DD0, same thing I have done. So, let me change it. So, it will be once again D2, by mistake I have done it, C2 C1. So, once again A1 B1 C1 and this is DD0. See, there is no difference between this connection and the previous connection, A2 like that, here also this. So, that is why no variety is obtained. What I intended to do, let me correct that. So, anyway this is done. So, let me do it like this, so that you understand, because this I have already done. What I wanted to do is, I will make another valid delta connection, but this way, got the point. So, it will be like this. Then you say this is A, this is your B, got the point. I actually did same thing, and this is your C. So, in this case then the phasor diagram will be like this. What will be the phasor diagram now? On the secondary side, voltage A1 A2, here also it will be A1 A2, is not? This is the thing. Now, then, or I did once again same. Now, B1 B2 and parallel to this line, but B1 is connected to A2, is it? So, it will be like this B1 B2 and finally, C1 C2 like this and C1 is connected to B2. So, it will be like this. Now, it is correct, C1 C2, got the point? So, in this case if you do, then people say that this is a DD0 connections sort of. Why I am telling? People say I will take output from A2 B2 C2, if I take, it is indeed DD0. Got the point? See, in this particular case, it is like suppose I say that you take the output from A2, B2, C2, then it will appear as a DD 180 or DD 6 connection. If output is taken from A2, B2, C2 instead of this one. That is, you take the output from say this you say A, this you say B, this you say C. Okay, in this case you can compromise a bit and not that much. A1, for example, Y6 star 6 connection. What do? You have to take output from A2, B2, C2, A1, B1, C1 shorted, but nonetheless the phase sequence is maintained and things like that. So, this is the I will circle it with red A2, B2 and where is C2? C2, A2, B2, 180 degree apart. Therefore, you see there are various ways of connecting the windings, delta star, delta delta, star delta, star star and so on. Now, in my next lecture, what I am going to tell you is about a transformer which is a 3-phase unit. It is built as a 3-phase transformer, at least some little bit of constructional features. Of course, the connections here I have mentioned, I started with 3 identical transformers. These connections things will be equally valid, as we will see if there is a 3-phase transformer as a single unit. So, we will do that in the next class. Thank you.